Hello, this is Dampro. Welcome to another Wonder Rigging tutorial. First off, I want to start by saying thank you and welcome to all my new subscribers. I honestly didn't think I would ever get 100 views, let alone 100 subscribers, and I know that's not a lot compared to other people's channels, but I just want to say thank you and I appreciate it. But more than my subscriber levels, the only reason I'm making these tutorials is really just to show that rigging isn't really that hard if you know a few simple concepts, and I hope everybody's getting that out of these tutorials, that it's not that bad once you get down to it. So I'm just going to continue making these tutorials, and I hope by doing that we can really grow the Wonder rigging community. And once we do that, I think we're just going to get a lot more animations and animators. So that's really my main goal. So let's get into it and do something a little bit different than my Rigify tutorial series. And I just want to say I apologize if you're waiting for me to finish those. I just needed to take a quick little break, mainly for my own sanity, and do something a little bit different, because it's not always about creatures and character animation. Sometimes we need to do mechanical objects, and so I'm going to do the ultimate mechanical object, this steam locomotive. So I just want to play this animation here. This is a great model and rig that was created by Trainboy1. I found this on blundswap.com. Like I said, this thing is absolutely beautiful. I believe he modeled everything to real world size, and everything moves and works like you would expect. He did all the texturing. So I just want to make sure that you know that he did all the hard work. I'm just going to kind of piggyback off that a little bit and re-rig this so it's not that his original rig is bad, but I just want to package it in a little bit different way with a single armature, just to make it a little bit more animation friendly and a little bit more usable and reusable. So let me just show you the final product here. So this is basically all of Trainboy1's hard work. I've just taken all the mesh objects that he created to create that train and re-rigged it to a single armature, and added a few custom shapes and things like that. Let me just play my animation here, and you can see I've got all the moving parts, the things that you would expect, and I added some more functionality to it. I don't believe the original rig we were allowed to, or there was a easy way rather, to translate this this rig across our scene, but just by simply changing my animation here, we go now we're going to rig this so we have this functionality. Now something else that I added rather is this root bone, and that root bone is important because like I mentioned before, this train was, I think, modeled for full size. So just to make it a little bit more reusable, this root bone is going to allow us to scale this down. So instead of having a full-size train, we just do RZ here, drag this around, G, Shift Z, and we could bring this train rig into another file and use it as a toy train. So if we wanted to have it go around a Christmas tree or something like that. So I think that's something that's often overlooked, is making our rigs usable and reusable. So, and root bone is actually the thing that's going to make that all possible. Well, let's get in here and start rigging. I don't want to get too preachy about different stuff, but I'm going to introduce a lot of different concepts and just try to tell you how I approach rigging and why I do what I do, basically to increase the reliability and usability of all my stuff. So I actually went through and categorized all of these different meshes into two main categories. So what I'm going to do is just re-rig all of the main parts that make up Trainboy1's train here. And I've got this first layer here. I've actually separated all these objects out. There's 108 different mesh objects that make up the engine and the main parts of the car. So we can actually rig these, all 108 of those objects, to basically two bones and an armature. So it's going to be very simple. And then I have on the second layer here, I have all the objects that make up all the moving parts, so the wheels and the pistons and whatnot. And I think looks like 75 objects there. So all told, there's 183 different objects that make up this train. But don't get scared away here. we're going to do this with an armature like I mentioned, and it's not going to be that bad. Alright, so let's start where I always start with every rigging project, and that is always mesh preparation. So there's something we can do that's very simple that's going to increase the reliability of our rigs. Before I attach any mesh to an armature, I always like to check for unapplied transforms. So if I start clicking through these different meshes, what I want you to look at is the transforms in this end panel over here, and what I'm looking for is locations that are not 0, rotations that are not 0, and scale values that are not 1, 1, 1. Scale values of 1, 1, 1, that means unscaled in Blender. And pretty much every one of these objects have some level of unapplied transforms. So what unapplied transforms means is these objects are not in their default state. So if we put them in their default state by selecting them, I'm just going to select them all 108 objects. I'm going to clear their transforms, Alt G for location, Alt R for scale, or rotation rather, and Alt S for scale, and you can see all these meshes kind of blow up. Now obviously we don't want to do that. But you'll look at the transforms now, they're all zeroed out. So we want those objects to be, let me just back this up 3 times here. We want all these objects to be in this position and those transforms to stay 0, so they're in their default state. So we can do this by first Alt P. What we want to do is clear the parents from the current rig, and we want to keep transformation so they stay exactly where they are, the way we're looking at it right now, and it doesn't look like it did anything, but it did clear that parent and everything is stationary now. It hasn't moved. We can do Control A. We can apply our location, rotations, and scales to all those objects, and now our transforms read 0, 0, 0 for location and rotation and 1, 1, 1 for scale. So now if I select everything and do Alt GRS, nothing moves, and if we accidentally move anything, either accidentally or even on purpose, we just need to move something out of the way, we can work on things. We have this default location. I just select everything, Alt GRS, everything goes back to the spot. So very important to make sure that our mesh objects that we're going to rig do not have unapplied transforms before we rig them to our armatures. So if you've done some mechanical rigging and rigged with empties before, you may be saying, Dan Pro, you are an idiot, you just screwed all of these meshes up, because now we can't rotate them in a logical way. But that's actually not important right now, because when we parent these meshes to bones in an armature, those meshes are going to inherit the locations and rotations and scales of the bones we parent them to, so we don't have to worry about the individual object origins. You'll notice everything's got an object origin here right down at the center. Once we parent it to a bone, those meshes are going to move with that bone, not because of their object origin. So this is actually a very safe thing to do, and I recommend you do this. It actually comes into play quite a bit more when you're using Armature Deform. If your mesh objects do not have or have unapplied transforms, you can actually get some really screwy auto weighting. I won't get into that right now, but applying your transforms is not ever going to hurt anything, especially when you're rigging with an armature, which was what we're going to do. Now let's start by adding an armature here. Just like we have unapplied transforms here, you'll notice everything's object origin is the center of the world. We want to do Shift S, make sure our cursor is at the center of the world. That puts it right there. So when we add our armature with Shift A, let's add armature single bone. That's where it's going to add it. And all these turn on X-ray so we can see that through there. Now I've actually went through and added an armature and some bones to that armature ahead of time, and that's basically just to save time. You don't have to watch me do some boring stuff here. So let me just delete this, and I'll turn on this layer down here which has my armature on it. Let me go to turn off some of these extra layers here. So we can start with 3 bones in our armature. Now, like I mentioned, I added a few bones ahead of time, and the reason for that was just to save time in this. I will just quickly tell you how I align these bones in edit mode, and then we can do the real-time parenting, and I can show you how to add the constraints. But so the first bone in the armature is called the root bone. I just renamed it root. Let me just change this train rig from 000 there. Alright, so the first bone in our rig is going to be that root bone, and I've talked about this a little bit before. This is going to be the rootmost bone in our hierarchy. Every other bone in our rig is going to be some way either directly parented to it or parented to another bone which is parented to it. So everything is going to find its way down the hierarchy to this bone right here. Now the important thing we need to do when we're adding that root bone is we need to align it with the axes of the world. Everything is going to be part of it. Everything is basically going to be, you can almost think of the other bones in the rig as living inside the space of this. So to make things make sense for our animators, so when we type GY and it goes the right way here, we are aligning this with the world. If you don't know how bones work, there's basically a bone is made up of two vertices. And these, this will be the head, that is always the fat end of the bone, and this is the tail, that is going to be the thin end. The y-axis is always going to run the length or in between these 2 points. So that's why I lined it this way. You can see the green axis here of the world's going that way, and this x-axis. Actually, maybe I can just hide these here quick, just so they're not confusing here. I have axis display enabled in my armature display options. You can turn that on or off right here. Y-axis is going here, x-axis is going with the world, and z is going up and down. Now Blender, I think, is actually, this display for axes is on the wrong end of the bone, because like I mentioned, the important end of the bone is always the head. If we just go into pose mode here and I select that, if I rotate this around, it's not rotating over here, it's rotating from that head position. So this is where the rotation is going to be calculated from. This is where we change the location. This is where that location value is being calculated, or even the scale values. That's where it's all being calculated, so we can scale on specific axes. Now, I won't get into too much detail on axes, but location and scale is always going to be along an axis. So if I scale on the x-axis, it's going to scale along it. If I move it on the x-axis, it's going to move along it. But a rotation axis is always going to rotate around that axis. You can almost think of that as a pin. If you had a Pinocchio doll or whatever, the pins in the knees that make things work, I always think of those axes for rotation as a pin. I'll just constrain that to x. So let's not get too far into the nitty-gritty here. I just want to talk about these other 2 bones, and like I mentioned, we're going to parent 108 of these meshes to 2 separate bones. So the first one is going to be this engine main bone. Let me just get to side view here, and I just align this pretty much with the world here, Y, X, and Z up, and then I just put it, placed it at the, so the head was about at the center of my train, which is about the center of this wheel right here. Now on this other one, my car main bone here, I decided to put this at the pivot point. The head of this bone is aligned along, well, the axes are aligned with the world, and the pivot point is set where the car is going to attach to that train. So if we're looking at it from top down view, we'll be able to do a little side to side. If we're going around the corner, or if we're going up a hill, we'll be able to do a little pivot from that point. So let's actually attach all of our meshes to these bones. Let me actually deselect all the bones, and I'm just going to temporarily I just want this first layer of mesh items visible. Now we've applied all the locations, rotations, and scale. Now we're going to parent them to the bones to make them move correctly. So I'm just going to go to wireframe here, make sure that I have everything deselected, and I want to box select everything that's going to make up this car. Now I can turn on the layer with my armature on it. I'm just going to shift select the bone, car main, that I want to parent all those objects to. So I actually have 13 objects that make up that car. We parent objects directly to a bone with when the object or the armature is in pose mode. You Control P, set parent to bone. Now when I move this bone, all those objects are going to move with it, and they're going to rotate from the head of this. So let me just slide this out of the way here, deselect that bone. I just want to, deselect all of those objects here. I'm going to hide that layer again, make sure that I've only got the meshes that are associated with this engine selected. Just box select them again, turn on that layer so I can select our engine main bone, Control P, set parent to the bone, and very quickly we have a bone that's going to control all of these engine parts and a bone that's going to control all of our car parts. So that was actually, we just rigged 108 different meshes, so pretty impressive. Let's go back to, let me just get on a wireframe here. Let's go back to texture mode just so we can see some of the fine work we're doing. The next thing I want to do is set up my parenting for Alt-H to unhide my bones that I hid before. I want to set up the parenting hierarchy, so we do that in edit mode. I'm going to select my engine main, shift select the root bone, and do Control P, make parent with keep offset. So let's go to pose mode here so we can see what that does. When I move my root bone, this bone is going to go with it. If I rotate that root bone, it's going to go with it. If I scale it, it's going to scale relative to it. Now let's go back to edit mode. I want to parent my car main bone to my engine bone. So select the child first, shift select the parent last, or next rather, Control P, make parent with keep offset. Now let's go back to pose mode. Now if I move the root bone, it's all going to be the same. Rotate it or scale it, everything will be relative, but now I can move just the engine and that car bone, or I can move the car independently of that. So that's a pretty basic hierarchy here. I'm actually going to probably change this a little bit later just to make a parent switch, but I don't want to confuse that issue right now. But we basically have exactly what we want right now. Let's get in and do some the fun stuff here, which is the moving parts. Now I'm actually going to set up my rig basically so when I spin one wheel, I'm actually add a bone, so it'll spin this first wheel here, and everything else is going to spin automatically. So let's start this. I'm going to turn on this other layer, and I've already added bones for each one of these wheels, or the sets of wheels here, for the car and also the engine. Go to side view. Well, maybe. I'm going to go to edit mode of my armature, and let's set up our parenting. So I want to parent the engine wheels to the engine main, and I'm going to parent the car wheels to the car main, just so they go with them. So I'm going to select all four of these sets of wheels, then select my engine main last, which makes it the active object, Control P, set parent, keep offset. So now when I move this engine main bone, my wheels are going to go with it. Repeat that process for these. Now I've actually cheated pretty much on these wheels. Let's make parent keep offset. The reason for that is basically instead of making a wheel for both sides, I figured it would be far easier just to make one wheel since both sides of these wheels are going to rotate the same. I'm just going to cheat a little bit and use a single bone in the center instead of adding one on either side. So now that we've got our parenting set up, I want to pick our axis locks here. Actually, before I do that, let's actually parent our wheel meshes to the appropriate bones. Just that might be a little bit more visually better for you. So I'm going to, just holding shift, I'm going to click through, select all of these wheels, because what I want to do is the same thing I did with my other meshes. I'm going to do Alt P to disconnect them from their old parenting, and I want them to keep transformation. We have unapplied transforms on those meshes, so Control A. We're going to apply that location, rotation, and scale, and now I'm ready to parent each mesh to the appropriate bone. I'm going to select the mesh, shift select the bone, Control P, set parent to bone, and now if I grab this, it's going to go with that bone. I'll just rinse and repeat. Select the mesh, shift select the bone I want to parent it to, Control P, bone, rinse and repeat. I'm going to do this really quick here. I'm not doing it to try to lose you. I'm just doing it so you don't have to watch me do boring, repetitive things over and over. The process is always the same. Select the mesh, shift select the bone you want to parent it to, set parent to bone. Alright, and so now we are set. We have our wheels moving with the bones. Now, one thing I want to talk about, this is going to be my main driving force of the whole rig here. So when we rotate this first bone, it's going to make everything else work automatically. So what we want to do is actually set our transform locks up here. So when an animator starts using it, first thing we don't want to do is we don't want them to pull this wheel away from our engine bone here. So we're going to lock the location. So something else we don't want to do is individually scale this bone, so we're going to lock the scale, and we only need to rotate on one axis. So let's find out what that one is. I'm going to type RYY, and that's not the direction we want to go. RZZ, that is not the rotation we want. RXX, that is what we want. So when you add bones to an armature, they always come in as quaternions, and when we only need a bone to rotate around a single axis, it's always best just to use Euler rotations instead. So I'm going to change from quaternions, the quaternion rotation mode, to XYZ Euler, and then I'm going to lock Y and Z because those weren't the axes that I wanted, and now that bone rotates appropriately, and we can't grab it and move it out of its spot, or we can't scale it. Now, what I should have done too, for our engine main bone, we also don't want to, let me turn on this other wire so you can see the meshes that are attached to it. We don't need to scale this individually, so let's lock this, and let's do the same for our car bone. All the scale is going to be done in this rig from the root bone, so everything is going to be relative to that. We don't want to do this, we don't want the animator to be able to scale that and screw up any of our rigging, so that is why I'm doing that. Let's get back to our excuse me. Let's get back to our wheel rigging here. Another thing we don't want to do, now we've actually attached all of these meshes to these wheel rotation bones, we want to make it easy for an animator, so he or she doesn't have to individually rotate all of these things to create an animation. We are going to use this drive wheel as the driving force. So when I rotate this, I want all these other wheels to rotate in the correct rotation. So what I'm going to do is add a copy rotation to this bone. Since these two are the same size as this, we can just copy the rotation directly and we will get the same type of movements here. Let's go to our bone constraints, add copy rotation. We need to pick our rig here, which is train rig. We need to pick the bone we're copying from, which is drive wheel, and we're just going to change local space to local space here. I won't get into why right now, but let's just take a look at what that does. So when I rotate this one around its x-axis, this one automatically is going to rotate around its x-axis the same amount. So there's another way we can add constraints that's a little bit quicker, and the way we do that is to select the target bone, which is one we're filled in automatically over here. We can select this, shift select the one we're going to add the constraint to, and with shift control C we get add constraints with targets, and we can pick copy rotation. That auto filled in that we're copying the rotation from our train rig drive wheel. Now we just need to click local to local, and we have 3 sets of wheels rotating. Now we're actually going to run into an issue right away, because we can't copy the rotations directly to these other wheels because they're different size. So when we rotate this around, because it's a larger wheel, we actually need to rotate these smaller wheels at a faster rate, so we can't just directly copy that rotation. So I'm actually going to stop the tutorial right now, just because that's going to be a little bit more involved, we're going to do this with a driver. So we've got our wheels set up. We can I'll continue in our next video with adding drivers and figuring out how fast we need to rotate these other two to keep up with this one. So until then, good luck.